Lesson 6-5, Day 2. Please start out on the summary slide, summarizing what we learned in our previous lesson yesterday. Our learning target today is I can write and solve a system of equations for a word problem. So our essential question, we're focusing on what information you need. So our EQ says, what information do you need to write a system of equations for a word problem? So think about the different things that you need to have. Think about how many equations you should have, how many variables, and what our systems have looked like. Okay, our first problem says write and solve a system of equations. Explain the answer. The cost of two groups going to a movie is shown in the table. The first group has 2 adults and 6 children, and they paid $18. The second group has 3 adults and 2 children, and they paid $13. So what we're looking for is we're trying to figure out the cost for each adult and for each child. So A is going to represent my adult ticket price. Remember, you should always define your variables. So that means saying what they stand for. And then C can represent child ticket price. You can choose any variables that you want. You just need to define what they're representing. So our first group is going to give us our first equation. So adults and children, 2 adults plus 6 children in the group, they paid $18. Then my second group had 3 adults plus 2 children, and they paid $13. Now, we've worked a lot with solving systems of equations and creating our own opposites. On this system, I don't have to multiply both equations. I can multiply just my second equation by -3 because 6 and -6 are opposites. So if I distribute -3 times that bottom equation, my new equation is -9a minus 6c equals -39. And keeping my first equation the same, you can see that I have successfully created opposites to cancel out the variable c. You can always create opposites by flipping your numbers and multiplying both equations. Sometimes, though, it's easier to multiply just one equation. So this one, if I add my system now, 2 plus -9 is -7a, and 18 minus 39, or 18 plus -39, is -21. Dividing both sides by -7 gives me a equals 3. So the adult ticket price is a bargain, $3. Now, to find the price for each child, I can go back to either of my equations. I choose the bottom one because it has smaller numbers. So I'm going to go back to this one. A is equal to 3. So I'm going to put my 3 in for the letter A, like this. Remember, 3a means 3 times a. So I need to multiply. So 3 times a, and a is 3. 3 times 3 is 9. So 9 plus 2c equals 13. Now, finish solving this. So my letter C that I'm solving for right here, I have 2 multiplied by it, but then 9 is being added. So I need to subtract that 9 to cancel it. 13 minus 9 is 4, and then my final step would be dividing by 2. So C equals 2. So adults are $3, children are $2. Bargain movie. Next example. At a sale, Sarah bought 4 shirts and 3 pairs of jeans for $181. Julie bought 1 shirt and 2 pairs of jeans for $94. How much are the shirts and jeans, assuming that shirts are all one price and jeans are all one price? So write a system and solve to find the cost of each shirt and pair of jeans. So S can be my shirt cost. Again, you can pick any letters you want. J, jeans cost. And remember that each person, each purchase is going to be an equation. So Sarah got 4 shirts plus 3 pair of jeans for $181. Julie got 1 shirt plus 2 pair of jeans for $94. So I am going to cancel out the letter S this time, and I can do that by multiplying the second equation by -4. If I distribute that -4, I get -4S, -8J, and 94 times -4 would be -376. My top equation does not need to change because I've created opposites by multiplying only one equation again. Cancel out the S's, add 3 plus -8 is -5J, and then -376 plus 181 is -195. And since I'm dividing by a negative by a negative, -195 divided by -5 gives me a nice positive number of 39. So the jeans are $39 each. Now I'm going to go back to my bottom equation with the smaller numbers. 1S plus 2J equals 94. And I know the jeans are $39. So I can replace J with 39. So 1S plus 2 times 39 equals 94. 2 times 39 would be 78. 1S is the same as just S. So I don't have to have that coefficient there. So now if I subtract 94 minus 78, I have got the cost of my shirts, and that would be 16. So jeans were $39 each, and shirts are $16 each. Sample number 3. This one I think is trickier. Okay, this one's going to help you out in high school though, because when you take some classes in high school like chemistry, for example, you do a lot of mixture questions. So they're going to be similar to this, only involving chemistry. So Joshua took his jar of quarters and dimes to the bank. Quarters and dimes. Remember, quarters are 25 cents. Dimes are 10 cents. They told him that he had 282 coins and it was worth $52.50 when they ran it through that change machine. So Q is going to represent quarters for me. And then D can represent dimes. All right. So first of all, he had 282 coins. So that to me means that the quarters plus dimes, just the number of coins that he had, has to add up to 282. Then on my second equation, I need to consider the value of each. 25 cents for each quarter plus 10 cents for each dime. That gave him a total of $52.50. So take a look at this system. This is tricky. So one equation is about how many he had of each. The other is about the value. Now, to multiply, the opposite of 10 cents is negative 10 cents. So I'm going to distribute negative 10 cents on my first equation. So we haven't seen anything like this yet. So look at these values. If I multiply 282 times negative 0.1, I get negative 28.2. Okay, keeping my second equation the same, then I can add these together, and I've canceled out the letter D. So negative 0.10 plus 0.25 is positive 0.15. And then over here, if I add these, I get 24.3. So now if I divide, this is going to divide evenly. And I get 162. So Q equals 162. So I have 162 quarters. Then if I go back to my top equation, it's actually just one step to solve this because they had to add up to 282. So I know that my quarters are 162. So all I need to do in my second equation is subtract. So if I subtract the 162 quarters, then I'll see what I have left for dimes. 120. So 120 dimes and 162 quarters were in his jar. All right, our last example. Now this one, I gave you multiple choice options for the systems and for the solutions. So this is a little bit different. Mariana has a total of 40 cakes and pies. Okay, she has a total of 40 cakes and pies for a bake sale. The number of pies is 4 less than 3 times the number of cakes. Well, remember that if C is cakes and P is pies, similar to the last one that I just explained, she's got a total of 40. That means that they have to add up to 40. So this equation looks good to me, and so does this one. Definitely not the ones with subtraction. Now the second equation says the number of pies, so the number of pies is, that means P equals, pies is 4 less than 3 times the number of cakes. So 3 times the number of cakes, I see that here, not this one. So A is out. Now it was 4 less than. So that means you're subtracting 4 from something, So this one right here. So less is not adding, and this is the wrong order. So the correct answer for the top part is C. So this is going to be my system. So not this one. This is going to be the system that is correct. Now, let's say that you want to solve this system. I am going to use substitution this time. Remember, you could always take the answer choices and plug them in and simplify. I think it would take longer though. So substitution, P is all alone. It's equal to 3C minus 4, so let's replace it. So the new top equation is C plus, and then instead of P, I replace it with 3C minus 4 equals 40, like that. I can combine my like terms to get 4C minus 4 equals 40. Then if I add 4 on both sides, 4C equals 44. And then dividing by 4 gives me C equals 11. So cakes equal 11. So down on the bottom, I can see that choice where cakes equal 11 and pies are 19. I could plug those in and make sure it's correct in my system. So my first equation said cakes plus pies. Oops, wrong number. So cakes plus pies has to equal 40. That is definitely true. Then the next one says pies equals 3 times cakes minus 4. So 33 minus 4. Did I just put that in wrong? I did. Okay, I have to fix this for you. This is supposed to be a 29. There we go. So adding, okay, so 29 equals 29, perfect. And then the other one, 19 plus 11, I will fix that one. So it's 29. Done.